Okay, so this first one we want to take the derivative of it, but we need to rewrite it so the exponent is on top and not on bottom. So anytime you have a fraction, you can pull it out as a constant. So it's 8/3 times x to the negative second power. Then when we differentiate y prime, use the power rule. We take the negative 2 and multiply it times the constant that's out front. And then subtract 1 from the power, so negative 2 minus 1 is negative 3. I'm going to write that. See how it's negative 2 minus 1. So then y prime is equal to negative 16 over 3 times x to the negative third. Then you need to move the 16 to the bottom. The x to the third to the bottom. 3x to the third.
Years of Spanish, where you learn nothing. Like, I actually love Spanish and I learned a lot, but having
3
people
plus
just get 2 years of it
3
because I would like 2 words in Spanish.
I can say a word.
What do we need to do on this problem?
Spanglish.
Move the
Spanglish.
bottom.
Leave the negative 3 out front and then take this, since the entire bottom's in parentheses, this whole thing is in parentheses. I want to move it to the top and then I'll use a chain rule, yes. To the negative third. So we'll move it to the top, it's negative third, then it's a chain rule. So outside, yeah, to the negative third. Then the inside is x cubed minus x squared plus 3. Then we want the derivative of the out times the derivative of the in. Derivative of the outside is going to be 9. And this whole thing's y prime. Erase. Hold on.
Are we going to have a lot of problems like that tomorrow?
So y prime, derivative of the outside is going to be 9, because you have to pull that negative 3 out front. Let's just write down every step. Negative 3 times negative 3. Then subtract negative 3 minus 1 times the derivative of the inside, which is going to be 3 x squared minus 2x plus 3.
Is that the
Three zero.
X plus, nope, we dropped the 3 because it goes to 0. Then I leave the inside in here. Then I can just simplify what I can simplify. So y prime is equal to 9 times x cubed minus x squared plus 3 times 3x squared minus 2x. And this, I forgot the exponent here, so it's going to be negative 4. Then the only other thing, they're probably not going to make you full that out. But they probably will rewrite it like this. So take the 9 and distribute it to the 3x squared and to the negative 2x. So y prime would be equal to 27x squared minus 18x. Then this whole thing is to the what? So I could move it to the bottom. So that's more than likely what your answer choice is going to look like.
You need to just
Take the derivative of the top.
take the derivative.
Yeah, I would. The 1/3 works as like a constant. Remember, so I can just pull it out and just take the derivative of 4x to the third minus 5x plus 6. So,
1/3. Where the 1/3?
because there's a 3 on the bottom. So really, if I take this whole polynomial and put it over 1 and multiply it by 1/3, so I pull the 1/3 out. That's part of the separates it out, so it's going to make it an easier looking derivative. So f prime of x is 1/3 times 12 x squared minus 5, and then they may or may not put the 3 back on the bottom.
A whole lot easier.
I want to go ahead and factor the top into x plus 2 times x squared plus 2x plus 4. Now remember, I'll probably change the numbers up on this. I'm going to go to a different page.
So I don't memorize this one.
Yeah, well, you should have already seen it before.
I've never seen
I
it.
never.
Okay.
I've never seen it before.
It's a sum of cubes, so it could be like a to the third plus b. I'm just using letters, so just in general. A to the third minus b to the third. It could be either one.
Could it be cube too?
It could be sum or difference of cubes. You know how sometimes we have a squared minus b squared, and it factors into a minus b and a plus b. You remember doing that?
Yeah.
Okay, yes.
Okay, that only works with squares, but it has to be minus when you're doing squares, but in cubes it can be sum or minus. So the formula is it's a plus b, so you use the same sign. So if it's a sum of cubes, you use the same sign in the first parentheses. The second parentheses, you square the first term, a squared, change this plus to minus or vice versa depending on which other one is, multiply a and b together, and then square the last term.
I've seen this before.
We went over it like 3 times just in this class. So I keep the sign, then it's a squared plus ab plus b squared. The last one's always plus.
Can we bring that formula to our test?
So this is the sum and this is the difference of cubes. So how that works in this case, we've got x cubed minus 8, right? So I need to be able to write it as something to the third power, so it's x to the third minus, I need to rewrite 8 as 2 to the third. So really, like, this is my a and this is my b.
Oh, you just put it on layers.
So it's x minus 2. Ours is plus 8, so I'm going to use minuses. So that's x minus 2. Then the first one's x squared, because I have to square a. Plus, because I changed that sign, 2x plus 2 squared, which is 4. So that would be that. That'd be x cubed minus 8 factored. So going back to this problem, then we have x plus 2 on the bottom, and since this is multiplication, it's one term times another term. These two terms would go to 1 because it'd be divided by each other, or they cancel out as we call it. So it's x squared plus 2x plus 4. Wait a minute, I didn't change the sign. This should be a minus. Did I do that yesterday? Oh. So,
Take the derivative out of that.
yeah, so then I just have to take the derivative of this polynomial. So y prime is equal to 2x minus 2.
That's the answer.
Number 5 is a chain rule, and it's a fairly common chain rule. Sine of 3x. The outside is going to be sine, and the inside is going to be 3x. Derivative of the outside is cosine, and you got to leave the inside in there, times derivative of the outside is 3, so it's 3 cosine 3x. So it's just a bunch of power rules combined. Alright,
That sucks though. Y'all done it before. Like walking to the wrong room, you just stand there. Like that's a bad first experience. Like,
so we need to pull the 4 out, subtract 1 from 4, which is 3, minus the fraction could be a little tricky. So it's 3 times 3 over 2. Hopefully you are getting more comfortable with fractions. as much as we've done this, minus 6. So 2 times 5 is 10, 2 minus 1 is just x to the first, and then negative 6x, you just drop the x, and 2 goes to 0. Clean it up just a little bit, so it's 4x cubed minus 9 halves. And I left the x off up there. Y'all gotta catch me before I write all this down. It's x squared plus 10x.
Get you. I'm over here
That's
like,
six.
what is math?
I make mistakes a lot.
Same. That was.
That's how easy it is to make a mistake. The negative 6 comes from the 6x. Up here, right. Product rule. F times G prime plus F prime times G. So you're taking one function the way it is, taking the derivative of the other one, and then flip flopping whichever one you did first. Taking the derivative of that one and then leaving the other one the same. So let's just let F and G. There we go. That's why I normally do it. Just whichever one's first, I'd do F and the other one's G. So leave F the same. So that's X times. Record any of this. F prime is 1, and then G is sine X. So we got X cosine X plus sine X, because 1 times sine X is just sine X. Well, it's Y prime. I always forget to do that. Yes, that's the answer. How to rewrite these as exponents.
Listen, when the report cards come out, you better.
Rule. So bring the 1/3 out front, and then it's x 1/3 minus 1 minus 2/3 x to the 2/3 minus 1. So y is equal to 1/3 x minus 2/3 minus 2/3 x to the negative 1/3. Then you can move the exponents to the bottom, and x to the 2/3 is the same thing as the cube root of x squared. And undo. Those are prime. So derivative of tangent is secant squared, right? So this one is the tangent of the square root of 3x minus 1. So actually this is like a chain rule inside of a chain rule. What's the outside function here? The outside is tangent. What's the inside? Right, if I take the derivative of the outside, it's going to be secant squared of the square root of 3x minus 1. What's the derivative of the inside? How do I take the derivative of that? Yeah, right. So it's a chain rule. So you can change it to 3x minus 1 to the 1/2. And then it's a chain rule where the outside is something to the 1/2. And the inside is 3x minus 1. So the derivative of the inside is going to be 1/2 3x minus 1 to the negative 1/2 times 3, because the derivative of 3x minus 1 is 3. Does anybody got any questions on how I got any of that? So then I can't really combine anything, but I can get rid of that negative exponent. So since it's a negative exponent, there's going to be stuff on top and bottom. This 3 will go on top, and since there's a 1 on top of that fraction, it'd be like 3 times 1, so 3. So just 3 on top, times secant squared of the square root of 3x minus 1. Okay, so then the bottom, I'm going to have what on the bottom?
3 over.
I'm going to have a 2, because this 2 is a fraction. And then I'm going to have
Root 3x minus
Square root of 3x minus 1. Any questions on that one? That one's that's a tough one. This 1/2 is like, you could really, so I'm going to have something over 2 as my fraction. I'm just making it one big fraction, and since this is already a fraction, whatever's on the top of that fraction will be on the top, and whatever's on the bottom is going to be on the bottom. But 1 times anything is 1, so I really don't have to write the 1 on top, since there's other stuff on the top. If there was nothing else on the top but the 1, then I'd have to write the 1 on top. But
Okay, because I was like distributing the rest of myself.
do you see it? Hold on just a second.
Was it like, had like